Welcome to this explainer. Today we're taking those fragile AI prototypes and transforming them into rock-solid, production-grade applications. If you're building with RAG, Retrieval-Augmented Generation, you are definitely in the right place. Let's get right into it. So does this sound familiar? You follow a tutorial, and everything works perfectly for, say, 10 documents. But the second you try to scale up to 10,000, the whole thing just completely shatters. Trust me, you are not alone here. The brutal reality right now is that about 90% of RAG systems actually fail in production. And the craziest part, they're all failing for the exact same reasons. There are basically 5 predictable culprits bringing these systems down. First, bad chunking, where your document literally gets split right in the middle of a thought. Then there's embedding mismatch, which is when your user's vocabulary just doesn't line up with your documents. Third is retrieval noise, basically the AI pulling in irrelevant garbage. Fourth, context overflow, where the language model just gives up and ignores half of what you send it. And finally, hallucination. That's when the model just confidently makes things up out of thin air. To fix all this, here's our game plan for today. We'll start with the reality of production RAG. Look at why chunking is actually an architectural choice. Master vectors and embeddings. Explore the hybrid search solution, and finally learn how to properly debug the black box.
All right, starting off with part 1. The reality of moving from a prototype to production.
Look, before we can fix anything, we really have to understand the foundational pipeline. The indexing phase is a one-time process, and it has 4 very strict steps. First, you load the raw documents. Second, you split or chunk that text into smaller, manageable pieces. Third, you convert each of those chunks into a vector using an embedding model. And fourth, you store those vectors in a vector database, like Chroma or Pinecone. Now here's the catch. If even a single step here is flawed, your entire RAG system is just going to return absolute garbage.
Which brings us to part 2, and this is a big one, splitting your text properly, because chunking is actually architecture.
I really want you to remember this mantra. Chunking is not pre-processing, it's architecture. The decisions you make right here are going to ripple through your entire pipeline. If you use bad chunking, like, say, blindly slicing text every 500 characters, you are literally shattering complete concepts. It's like taking a photograph of a person, tearing it into tiny confetti, and then asking someone to find the person smiling. If the smile gets split across 2 different pieces of paper, neither piece actually shows a smile. You've completely destroyed the meaning.
So how do we fix this? Our first tool is overlap. Think of overlap as a really cheap insurance policy. Imagine you have one chunk that ends with a problem, and the very next chunk starts with a solution. If you don't have overlap, those 2 ideas are separated forever. But if you add a 50-character overlap, for instance, that little bit of redundancy ensures the problem and the solution stay tethered together across the boundary. You make sure your context isn't left orphaned.
Now, there are a few different strategies for doing this. Fixed chunking makes arbitrary character cuts. Honestly, never use this in production. It's really just for quick prototypes. Recursive chunking, on the other hand, is your reliable workhorse. It splits at natural boundaries, like paragraphs and sentences. That's going to solve about 80% of your standard use cases. But if you're dealing with high-value accuracy needs, think legal or highly technical docs, semantic chunking is your premium option. It actually analyzes the embeddings and splits the text exactly where the underlying meaning shifts. It's pretty amazing.
Moving on to part 3, mastering vectors, embeddings, and semantic space.
There's actually a huge point of confusion I see all the time here. People think chat models and embedding models are the same thing. They absolutely are not. When you're typing to ChatGPT or Claude, you're using a chat model. Text goes in and text comes out in a conversation format. But an embedding model, it takes text in and outputs a vector. That's a massive list of numbers that represents the pure semantic meaning of that text.
And when I say a massive list, I mean massive. Take the number 1536. That's the exact number of dimensions in OpenAI's Text Embedding 3 small model. But what does a dimension actually mean in this context? Well, the more dimensions an embedding model has, the more room it has to capture semantic nuance. It literally creates more space to hold the different features and subtle meanings of your text, which allows the underlying math to accurately compare the distance between concepts.
Okay, part 4. Let's talk about fixing retrieval noise with the hybrid search solution.
So, vector search is basically magic when it comes to semantic meaning. If a user asks, "How do I authenticate?" the vector search is smart enough to look for login credentials. But here's the flaw. It completely fails on literal strings. If someone searches for an exact product SKU, like SQ7742X, or maybe a very specific error code, the vector search just sees a meaningless string of characters and hands back total garbage. That is exactly where BM25 comes in. BM25 does not care about meaning at all. It's a keyword champion that just counts words, making it absolutely perfect for exact matches.
The big takeaway here is that you shouldn't rely on just one or the other. You need both. When a query comes in, you run a vector search and a BM25 search in parallel. Then you combine them using something called reciprocal rank fusion. It's this brilliant mathematical fusion that takes the results from both sides and naturally balances semantic relevance with strict keyword precision. Documents that rank well in both searches naturally bubble right up to the top, so you're literally getting the absolute best of both worlds.
Finally, part 5. We need to talk about RAG observability and debugging the black box.
I love this quote. Without observability, you're debugging by reading the final output and guessing. It's a harsh truth, right? In traditional software, if something breaks, you get a stack trace. You know exactly what line of code failed. But with large language models, you just get a super confident, completely hallucinated answer. There's no stack trace. You have no idea if the search agent failed or if the analyst agent just misinterpreted the data. Without visibility, you are literally flying blind.
The fix for this is using an observability platform like Langsmith to transform that unpredictable black box into a fully measurable system. This relies on 3 main pillars. First, you have traces, which track the exact flow, the agent's decisions, and the tool calls step by step. Second, you get metrics. This lets you track your token usage, your latency, and your exact costs down to the penny. And third, evals, which mathematically score your response correctness over time. Once you have this in place, you aren't just guessing anymore, you're actually engineering with data.
So I want to leave you with a final thought to chew on. Is your RAG system relying on solid engineering, or is it just relying on hope? If you're constantly fighting bad chunks, broken retrieval, and silent failures, it's time to stop hoping and start architecting. Thanks for hanging out with me for this explainer. Go take these principles and build something truly production grade.